beam question. This type of stuff is very popular in engineering, mechanical stuff, so it's good to have a good understanding of it. Here's my beam, no mass again, ignoring the weight for now. It's 5 meters long. It's got 20 Newton force there. We've got to find what RA and RB is. So I'm going to use moments, force times distance. I'm calling clockwise moments positive. And this beam is in balance. I'm going to have balance down here. All that means is everything adds up to 0. Force times distance. Here's my first force. Here's 20. Here's my pivot point. I'm going to go from there. Pivot point for now. How far is 20 from my pivot point? It's 2 meters. That force is trying to make this beam do this. It can't because that thing's in the way. Trying to find that thing. 20 times by 2. There's my one force. I've got another force over here. RB times by how far is RB from here? 5. Bracket. Which way is it trying to go? If it could, it'll go anti-clockwise. I've got minus. The beam's in balance, so that's going to add up to 0. I'm assuming that's 40. And move this across to make it positive. RB times by 5. 40 divided by 5 will give me RB, which is something like 8. 5 is 40. RB is 8, which means RA has got to be 20. Coming down, take away 8. RA has got to be 12 for this beam to be in balance. Handy thing to know, over now. Another beam question, very popular in exams and coursework in engineering, or A-levels, things like that. So at this time, I've got a beam with a mass, no point load. So we need to work out what happens when you've got UDL. Here's my beam. I'm going to give it a length of 5 meters. It's got a UDL, which is equivalent to the mass, uniformly distributed load of 3 newtons per meter. That means it's 3 newtons every meter. This thing's in balance, and assumes in balance. We need to find RA and RB. The way you deal with this is, I'm going to convert the UDL to equivalent point load. So I'm going to do 3 newtons per meter times by 5, because it's 5 meters. That gives me 15 newtons equivalent. What you do is you put that halfway, because the UDL acts across the entire length of the beam. So you put it halfway of where the UDL acts. 15, and it's 2.5 meters in. That's equivalent. Makes it easy for us. Now we're going to work out RA and RB. I'm going to do force times distance. Moment is force times distance. Pivot point is there. The 15 newtons, the UDL wants to do this clockwise. RB wants to go the other way. That's the reaction. Force times distance is my first force. 15 equivalent. Times 5. How far is that? Oh yeah, 2.5. Go clockwise, like that. We're going to one more force. RB is the reaction. How far is RB from my pivot point? 5. Which way is going? Anti-clockwise. This beam is balanced. All add up to 0. Thank you very much. Do a bit of maths. That's 37.5. Bring this across to make it positive. RB times by 5. So 37.5 divided by 5 will give me RB, which gives me 7.5 newtons. Which makes the sentence of 15 smack in the middle. So that's going to be 7.5. And obviously RA is going to be 15. Take away 7.5. Which also gives me 7.5. What goes up comes down. 15 coming down, 15 coming up. Beam with a UDL stroke mass. Over and out.